We're going to talk about discriminate. Discriminant of a quadratic equation is the expression under the radical sign in the quadratic formula. So if you look at what we have under the radical, b squared minus 4ac, this would tells me how many or what type of solutions do I get. Because if b squared minus 4ac is equal to 0, how many solutions do you think I would get here? I would get minus b plus 0 over 2a, and I get minus b minus 0 over 2a. But those would be identical solutions then, right? So I only get one solution there. So in other words, if b squared minus 4ac is equal to 0, the quadratic equation has a single real number solution. If b squared minus 4ac is greater than 0, if it's greater than 0, the quadratic equation has two distinct real number solutions. If it's less than 0, if b squared minus 4ac is less than 0, anybody can guess what's going to happen? We get negative number on the radical. It means we get what kind of solutions when you get negative number? We get those negative radical, we get I. We get those not real, complex solution, not real solution. So if b squared minus 4ac is less than 0, the quadratic equation has no real numbers. You get those I appears in our solutions. So if you look at the graph of these, the graph of second order equation looks like a parabola. We're going to look at the graph of parabola in great detail later. But this would be an example when the discriminant is positive. When it is positive, then your parabola going to intercept the x-axis at 2 points. That's why you get two solutions. This would be an example where b squared minus 4ac turns out to be equal to 0. That means in this example here, your parabola going to only intercept the x-axis at 1 point. This is where you have what you have under the radical equal to 0 in the quadratic formula. And finally, if b squared minus 4ac is less than 0, that would be an example where the parabola appears where it never intercepts the x-axis. So this could have happened that the parabola would be up here or down here, never intercept x-axis. So there's no real solution for this. That's why we get those imaginary solutions. So here's your turn to see what kind of solutions are we going to get for these 4 examples. What you need to do is to evaluate b squared minus 4ac for each of these and see whether it turns out to be positive, negative, or 0, and then decide whether we have one solution, imaginary solution, non-real solution, or 2 real solutions. For those of you watching this later at home, you may want to pause the session at this point and compare your answer in a few minutes. Okay, let's see how to find the number or type of solutions we have by finding the discriminant. Can somebody tell me what did you find for the first problem here? Okay, Lambert, do you have a question? Do you want to tell me? Go ahead. Okay, the first one is, first we have to find out the values of a, b, and c, right? A is equal to 1, b is equal to minus 12, c is equal to 36, and then we want to find b squared minus 4ac. What is that equal to? 0. Then you get 0. If b squared minus 4ac is equal to 0, then there will be only one rational solution. This would be where a case that your graph intercepts x-axis at 1 point only, like this. So one rational solution. For b, a is equal to 1, b is equal to minus 20, c is equal to 7. Discriminant would be b squared minus 4ac, which is equal to what? Anybody? What did you find? Would be greater than 0. This would be where b squared minus 4ac is greater than 0. Then you get 2 real solutions, and this would be the case where your graph going to intercept the x-axis at 2 points. In this case, you would get 2 irrational solution because you get square root of 428, irrational solution. Next example, your a is 5, your b is 7, and your c is equal to 1. So b squared minus 4ac would be equal to what? What did you find for the next one? Anyone? Get 29. You get 2 irrational solution. Next example, your A is equal to 1/2, your B is equal to 5/4, your C is equal to 2. First you have to write this in standard form, and then your discriminate would result into what? What did you get for the next one, anyone? 5/4 squared minus 4 times 1/2 times 2. They give you a negative number. When you get a negative number, it means you get two imaginary solutions, or if you look at the graph, you see that the graph would be such a way that never intercept x-axis.